Similarly, if we put a minus sign in front of these, it will rotate it around the x-axis. If we put a positive constant number up here that's bigger than 1, we'll stretch it out. If we put a fraction, we'll shrink it. Incidentally, we're going to start getting into this. The number that's in front of this, sometimes we'll write it like this, sine kx. This is called the amplitude. And basically what it's telling you is how high up it's going. Okay. There's one more function that I want you guys to be familiar enough with to be able to draw, just because these show up quite a bit. The sine and the cosine, you just got to know. The one other one that makes a very regular appearance is tangent. And this is what I'm going to do. Yeah, that'll be enough. So what does the graph of tangent look like? And we need to think about this a little bit. Remember, tangent x is sine x divided by cosine x. We know that sine x and cosine x themselves are bounded by 1, an absolute value. The absolute value of sine x is less than or equal to 1. The absolute value of cosine x is less than or equal to 1. What that means is that both sine x and cosine x, and I'll do this, I'll cheat, are trapped between -1 and 1. However, tangent x is not, because we're dividing by cosine x. Remember, cosine of pi over 2 is 0. As we are dividing, we're getting closer to 0. What is sine of pi over 2? Sine of pi over 2 is 1. So this number is going towards 1. And this number is going towards 0. What that means is that this is going to blow up. So this function looks more or less, actually, let me draw these in. It's more or less like this. It is undefined at pi over 2 and negative pi over 2 because that's where cosine is 0. And it looks something like this. That's just between negative pi over 2 and pi over 2. It also continues on like this. And I'm not going to keep drawing. I think that you get the point. And it's going to be discontinuous at anything where cosine x is 0. And where are the places that cosine x are 0? Cosine x is 0 whenever x is equal to what? Well, we have pi over 2. What would happen if we went around again? It would be plus 2k pi, where k is some integer. Also, cosine x is equal to 0 when x is equal to negative pi over 2. And we can still add any, if we're going around the circle, we can still add 2 pi or subtract 2 pi, whatever we might like, and it will still be 0 then. And I'll put this. So basically this function is periodic, and it looks the same all the way across, but anywhere where x is equal to one of these, and the primary ones that you want to think about are pi over 2 and negative pi, it's going to be discontinuous. So what is the function's period? Well, the period means where it repeats itself. From this stretch from negative pi over 2 to pi over 2, the period is pi. And I hope you can see that every pi, it just keeps repeating itself. These three functions, sine x, cosine x, and tangent x, you should know how to draw these basic graphs. I think that's important. And if somebody says sine 2x to you, you should be able to, whether you need to draw the graph or not, but you should understand what's going to happen to it. Incidentally, what would sine 1/2 x be? Suppose we want to know something about this. What's going to happen here? Well, it's important to know how to figure out the period. The period for anything that looks like this, sine kx, is going to be, the period is 2 pi divided by k. So in this case, when k right here is 1/2, The period here is going to be 2 pi divided by 1/2. Division by a fraction is same as multiplication by the reciprocal. We just flip it around and multiply it. This is 4 pi. So think about what happened. If we put a 1/2 inside of here, what we've done is we've stretched this thing out. We've made the wave nice and long. A number greater than 1, it makes the wave flutter faster. What about a negative number? Oh, good question. What's the graph of cosine minus 2x look like? Well, we know that cosine is an even function, so that means that cosine of negative 2x is the same as cosine of 2x. Even functions kill off the negative signs. I would like to put this up just so you can see this. And let's just see this. So we're going to do 2x, which means instead of going pi over 2 and pi, I'm going to cut those in half and go to the fourths. So we're going to say that this is pi over 4. Well, I guess I'll put these up here too. Pi over 2. Here is 3 pi over 4. Here is pi. Here is 5 pi over 4. Here is 3 pi over 2, which is in fact 6 pi over 4. Here is 7 pi over 4, and I didn't make it quite big enough. Here is 2 pi. So let's graph this and see what happens. When x is 0, cosine of negative 2 times 0 is still cosine 0. I should probably put these up here, 1 and negative 1. We still start here. When x is pi over 4, negative 2 times pi over 4 is negative pi over 2. Cosine is an even function, so the value of cosine negative pi over 2 is still going to be the value of cosine pi over 2. It's just going to be 0. The cosine of negative 2 times pi over 2 is the cosine of negative pi, but the cosine of negative pi is the same as cosine of pi is negative 1. Similarly, so I guess we have this. And once again, within the period of 2 pi, we see that it repeats itself twice. What would happen to sine negative 2x? Well, this is an important question. Remember, sine is an odd function. That means the minus sign comes out of it. So this means that this is the same as sine of minus sine of 2x. What happens when you throw a minus sign in front of a function? It means you rotate it around the x-axis. I'm actually not going to do it. Here's the thing about graphing. These functions, these basic graphs are important to have a feel for because they show up a lot in analysis. However, if you're going into the sciences and engineering, you are going to have computers that are going to draw much, much better graphs than these. And even if you have a calculator, a TI-83 or whatever, they will still do these very well. I'm not huge on making students spend hours and hours and hours on graphing functions. However, as I've said, the sine, cosine, and tangent functions, it would be good if you had a really good feel for what they looked like, just the most basics. What would happen if you multiply a positive number in sine? What would happen if you put like 50 right there? We're going to be talking about more of that in a moment.